Hope you're all doing really great. Okay, so in this video, I'm going to show you how to solve a 6-marker questions related with energy transformation. Right. So this is a question I would like you to pause the video for a minute and try it out on your own. Okay, so let's continue. Right. So step 1, what I always would recommend to you to read the background information of the question and trying to observe through whatever the image which has been given. If it can be a graph question, it can be anything with an image or a toy or a car or anything. Read through, understand, observe, highlight the numbers which is associated with that, so that you will be able to get good understanding. Right. Step number 1, what I can always see that there is a stretched spring. Right. We know what sort of energy has been stored. Right. Stretched spring contains elastic potential energy, and as he is going to release the spring, it would help the toy aeroplane to fly away. Right. So moving toy aeroplane will contain kinetic energy. So based on the information which is given, I can easily correlate there is a stretched spring which provides elastic potential energy. The moving aeroplane contains kinetic energy. So that's the key information what we have already observed. Right. Now, step 2, we need to work out the energy transfer associated with that. We know elastic potential energy associated with the spring. We know kinetic energy. Well, in this case, as they haven't highlighted any energy loss, you can safely assume 100% of elastic potential energy has been converted into 100% of kinetic energy. So that's easy for us. Right. So what we need to do next, step 3, find out elastic potential energy. We know how to calculate elastic potential energy. We know the formula. Right. Next, we know the formula for kinetic energy. We already know elastic potential energy has been converted into kinetic energy. With that, we can easily calculate the speed. There you go. Next step, calculate elastic potential energy. We know the formula for elastic potential energy, 0.5 ke square. Now, watch out. Most of the students try to forget to use the calculator correctly to apply for the square. Either you can do 0.5 ke square, or you can say 0.5 ke times e, not to miss out anything. Right. Now, trying to read k spring constant, which is over here, and e extension has been highlighted here. So easy peasy, we can apply through 0.5 times 50 spring constant times 0.12 square. That gives us 0.36 joules as elastic potential energy. Okay, now step 5, we know, just a quick recollection, elastic potential energy has been converted into kinetic energy, as elastic potential energy over here is 0.36 joules. Kinetic energy is also 0.36 joules. All right, so what is the formula for kinetic energy? 0.5 mv square. So now we know kinetic energy, which is as same as elastic potential energy, 0.36 joules, and we know the mass which has been supplied over here, mass of aeroplane. So we need to calculate a velocity or the speed. Right. Step, very important point. Again, the common challenge for many students. First, rearrange the formula before applying it out. So v square equal to ek over 0.5 m. Remember, this is v square. You need to do a square root. Another common challenge. Many students forgot about doing the square root. So square root of ek over 0.5 m. Now we know this is as same as elastic potential energy, 0.36, and 0.5 m mass of the aeroplane, which is 0.12. There you go. You apply everything, you work out, and you will be able to calculate the speed as 6 meter per second. Remember the unit, very important. What is the standard unit for velocity or speed? Meter per second. There you go, easy. You are able to solve a 6-marker question in no time. All right. For more videos, follow us.